let's have a look of this guide mechanism. It's on the side at the moment, and it's connected to the wing mechanism with two coordinates. First coordinate is this little how to say, little element that goes into this hole here, or it could be installed in this side of the wing, depending on what angle cuts you want to make and which scale you are using. At the moment I'm only using that one. So this goes inside here, and this adjustment mechanism goes into or through this hole, and then it slides in that slot in here. So in theory this point is all the time fixed, although you can rotate the fence around that coordinate, and then here when you reach the angle that you were hoping for, then you can fasten it down so it would keep this angle. But there is a problem. Let's connect this to the machine. Okay, I loosely installed the guide on the wing. At the moment I haven't fastened it down yet, so I can regulate the angle. Let me go to the other side. So what's the problem? To achieve 90-degree cuts, it has to be perfectly 90 degrees related to this sliding mechanism, and it can be adjusted not in here, because this element that went into the hole is all the time fixed, but the other the depth of this movement can be adjusted by one screw inside here. So if it's out of the line, you can regulate it until you achieve the coordinate that you want, which I have done actually. It was also like 1 millimeter off, so I had to regulate quite a lot. But before I will fasten it down, I need to make sure that the fence itself is resting on some base coordinates that I'm always referencing it against you. What I mean by that is that the same hole in here and in here, let's say it's the same thing, only magnified. The part that goes inside of the hole in here is a little bit smaller, because otherwise it wouldn't fit in nicely. But in that case I need to decide before I will lock this mechanism down whether I bring this contact to this corner of the circle or in that coordinate of the circle, and because these are different coordinates, and it might a little bit change the cutting angle depending if my zero coordinate is in here or in here. So what I usually do is that I, first of all, as this can be moved that way as well, I don't want that. I will all the time pull it as far as possible from the sliding mechanism, which means that at the moment I'm resting in that corner of the contact, in that hole. But I don't want that one, because all the material is pushing to this side of the fence, so it would be logical that I will bring the contact in here, so it would be in the most stable equilibrium or something like that. So I apply some pull to this side and some pull to towards me, so it would rest in here. And as this contact in here against the bolt is already achieved, then I should be able to fasten it down. Okay, let's do that. Although I did it with one hand, let's assume that this is at the moment perfectly 90 degrees. But now the problem is that as I before told you, that when I'm moving the sliding mechanism up and down, the wing is raised and lowered, which means that and this is where most of the cutting inaccuracy mistake came in. The problem was that when the wing mechanism was raised towards the end of the machine, it tried to raise the fence mechanism as well, which meant that as this connection in here is already fastened down and this one can't move, then this this other contact needs to compensate the movement of this fence, because otherwise it wouldn't fit in between those two coordinates if they go closer by to one another. Although it's not going closer by in the sense of that it's both in the same element, but if the wing mechanism is raised from here, there will be additional pressure in here, and this will push the whole mechanism a little bit. Which means that if we come back to this analogy, then we had the contact in here, in this connection, but now when it's going closer to itself, it needs to move from here to here. So it means that the whole fence mechanism is a little bit adjusting itself towards this way, which again would mean that if we are having a 1 meter by 1 meter or 1 square meter material, then by that distance this small movement already creates massive mistake in the other end. So it is extremely important that this joint factor is so well adjusted that it doesn't create any lifting or lowering force on the wing during the sliding mechanism operation. I don't know if we can see at the moment, but we're almost maxed out with the fence at the moment, and there basically isn't any gap in here at the moment between the slider part and the fence. But when we run to the other end, maybe you can see the gap is slowly appearing. Let me change the hand a little bit. Now it's already quite noticeable. Okay, you get the idea. So this is quite big problem actually, and it is very annoying to regulate it out actually. Okay, let's speak a little bit about those fences. The one that came with the machine and the one which is an accessory. As you can see, they have the same profile, only one is longer than the other. And they both have the same type of flip stops. These flip stops are very good. These are extremely good flip stops, and this is one of my favorite items with the saw. I have seen that some models of SCM machines have a little bit different sort, more simple ones, but if you can get those ones, these are extremely good, stable, and very, very nice flip stops. But you can see that those profiles are different length, which is normal. They carry different purpose, but both of them have a different or have the same idea that you can extend the arm. And This profile that runs inside here, which is like a square pipe, doesn't cost anything. It's like, I don't know, one euro per meter or whatever, and the scale itself is probably the same, if even that. I don't have enough space on the table to show you, but and it's not a particular problem in my workshop because I don't have too much room, but it once again demonstrates the general idea that those additional parts that you can bring out are in different length. One would assume that a longer one would have a okay, maybe I can't show you that one's problem, but the longer profile would allow you have a longer bar inside, or this extension bar, but as you can see, you could almost fit twice as long element in there, which they don't provide you. And the shorter one has a significantly longer extension arm inside of this profile. I don't get the idea, because it would be so easy and so cheap for a couple of extra euros to give a consumer additional length for this fence, but I don't understand what the logic is behind that. Initially I thought that this might be something to do with extra momentum forces, because the longer the material you're installing the wood on here, the more force it creates, and etc. But come on, look at the second one. This has even a smaller support mechanism, and with that profile they do admit that it is possible to install a longer and heavier material there, and with this more massive assembly they only give you that one. So yeah, nice.